All right, lads. What do you say we put this project away and finish the semester strong? So I cut the recording earlier. Go ahead and set a timer. I cut the recording earlier because I was running into some issues with my fit. And it turns out two things were going wrong. Thing number one was simply the fact that I had switched I had switched the uncertainty in my efficiency data points. I had like flip flopped these around because I had been fishing with them in the previous videos, and I just aligned them, and so that was skewing my data. So when I showed it to Dr. Daniels, he had noticed that, and then we fixed it. However, what I also pointed out to Dr. Daniels was like, hey, you know, I can't use three parameters in my fit function because I only have three data points. So that gives me 0 degrees of freedom. Python can't generate anything about my parameters. It just overfits the data effectively. And so that wasn't working. So then we realized, okay, well, you can only use two parameters, which is what I was already doing. However, my fits weren't very good. And so when I went to Dr. Daniels, we came to the conclusion, yeah, you can only use two. And so then we also came to the conclusion that with three data points, we're really not going to get a good fit. It's just not going to happen. And so the conclusion we came to is that we would need more data. And so we do have access to one more spectrum, but he didn't even list it, right? Because the peak fitting for that was really tough. He was kind of walking me through a little bit of it. And he was like, look, you want to be able to present this thing tomorrow. I don't really see that it's worth it. Maybe it's something we could work on separate research at a different time. And so we just decided that I would just highlight that deficiency in the data as part of my project presentation. And so what I'm going to do now, hopefully in the next hour, I got some coffee, I got my physics mug, and my cat, and so hopefully we can go ahead and crank this thing out so I can lay down and watch Oppenheimer and celebrate getting an A on my quantum final today. I don't know that for sure, but I was putting some work in. So, anywho, so what we need to do now is we need to sew up the rest of these things that he wanted me to calculate. So the first thing that I did while you guys were gone was I went ahead and plotted the individual fit components because I had forgotten to do that before. But what that does is basically shows the functions that we're adding together that give you the overall fit. Um, and then what I need to do is um, he wants me to report the best fit parameters in their error matrix. And so what I need to do is go into each one of these and print. Um, I need to print. So the best fit parameters for these, there's going to be multiple. It should be p-opt. Look at my fit function. No, I'm in Dr. Daniels. Oops. So it should be my fit function, which is taking in 6 parameters. So I want to print p-opt. Uh, p-opt means parameter optimization for anyone that doesn't know. So I should be able to slice this and print 0 through 6. I don't know. We'll see if that works. That's 6 parameters. Yeah. Let's see if Python yells at me for doing that. I might have formatted it wrong. Name it. Oh, oops, gotta rerun everything. I'm gonna have to do that every time I reopen Jupyter Notebook. And so, let's see if it yells at me. No, it was doing that dumb error earlier. Let's run it again, it'll go away. There we go. Okay, so it looks like here's our parameters: 106, 4490, 75, 14, and 455. Good. Now, Dr. Daniels will probably want me to print these separately. But what I'm going to do is just make this easier on myself. Need 2, 3, 4, 6, 7. And just grab these and print above it bit parameters respectively. Okay. Was never closed. Oh, duh. Oops. Okay. And so now that that's done, I just have to do that again for all of these. And so these all should be printing the same exact thing. So let's go ahead and print those. Good. Okay. And one more time. I will organize this code a little bit more, but I'll probably do that off camera because I don't think you guys really care about watching me organize things. Maybe you do. I don't know. I feel like you care more about me doing the actual physics stuff. So, well, now that's done. So, and their error matrix also, I gotta do all that. Okay, that's easy as well. So now I just need to print, why is that? Oh, because I'm in this again. So now I just need to print pcov I j. Will it let me print the whole thing that way? I don't know. We're gonna find out. No, it won't. That's fine. I think I can do with what 0, 0, 0, 1. I guess I could do why that's too much work. I'm just gonna do it this way. 1, 1. There's better ways to do this, but I really am not worried about that right now. I just want to get the thing done. And so 1, 0, and then 1. Oh, this would be 0, 1, 0, 1, 1, 0, and 1, 1. So the error matrix is a, oh wait, no, wait a minute. Oh, I would need, 5 to print the entire error matrix from curve fit. What do I do? Return the fit error in Python curve fit. Can I wait? I think I saw him do this in class. I can just write print pcog and it prints the whole matrix. It's just an array. Not gonna work. Yeah. Yeah, that's horrible. Jesus. It's a 7x7, so I mean that's what it's gonna be. Okay. Gross. Is there a way for me to print it better? Do I have to verify? Really? Coffee's still too hot. The covariance matrix. I mean, is that the only way? Where are you even printing those things? They don't even. They don't even have. They don't even have a print function in here. So where's your error matrix coming from, sir? What? Theirs is a 4x4, so it looks a lot better. Mine is freaking 7x7 because I have 7 parameters. It's gross also, but can I truncate this? I don't think that format will work. I think I want, let's see, F covariance, error matrix. If I can remember how to do this. 1.2 F colon space pcog. That definitely doesn't feel right. Yeah, no. Might have to be an E. Can I do it with an E? Let's see. How to truncate a matrix on matrices index. I don't know, it's elements. Elements. In a print. I know how to do this. It's just one thing I'm getting wrong. No, that's gross. That's not what I want to do. No. This is annoying. Let's see. I think I did this in one of my old projects. Let me just go look. I still got 15 minutes in this video. Maybe it'll be productive. I'm trying to make this not be 1,000 parts. Yeah, I did it. No, that's in class. I know that I truncated a matrix in this. Where did I do it? Here we go. Here we go. That's what it is. That's what it is. I need to do F, say the thing, put a colon, and then put the thing. So this should be pcog, and then 3.2 F. Or no, it was 1.2 F. Is that how I did it? 0.4. Yeah, all closed, and then parentheses at the end. That should print properly. No. Darn. Okay. Um, this isn't even the right document. Darn it. This? Yeah, there we go. I know I got it in here. With an integer. The array. That's the way I do it. That's the way I do it. For val in, yeah, okay. So I would say for val in pcov, uh, or wait, let me just val 0.3f. So I need this part. Val colon 1.2f close parentheses. And then in brackets, for val and gx. So for val. Please work so I can keep moving. Nope. Darn it. All right, well, guess we're just printing the whole thing. That's disgusting, but it's what we're doing. This is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row. Cool. So now I just need to do that for everything. So I just need to print pcov down here. And these are all going to be gross looking things. Yeah. I mean, it's a 7x7 matrix. What do you want? It's going to be ugly and long. Pointless, really. Well, not pointless because I'm going to use it, but pointlessly formatted Python. I tried 3 different ways and it didn't work, so I'm blaming you. Okay, so perfect temperature on the coffee. That's great. Okay. Hopefully my swallowing isn't horrible in the mic. Anyways, all right, what do we gotta do? So you guys can't tell, I'm like I've been up since 5:45, so and I took a 3-hour exam, so I'm kind of dead. But this is it, so home stretch. So now got the best fit in their error matrix. For each peak, calculate the following spectral variables and their uncertainties from the fit results. Be sure to include fit parameter covariances in the error propagation. Efficiency is the number of detected photo peaks counts to the number of emitted gammas. I already did that, already did that. But what I do need to account for is that the number of emitted gammas is the product of source activity, counting time, and gamma intensity. So I did not account for gamma intensity. So if I go up into my project, it's 0.851, which means that cesium gamma decays in this mode at that energy 85% of the time. I need to multiply that by my calculation for counts. So right here, it should be multiplied by 0.851. Yep. So if I do that, what does that change? It's going to change things around, but shouldn't change it that much. So it did give me a pretty, what's the efficiency? 43. Before I had, it's going to definitely change some things. I'm going to have to redo a lot of stuff. Before I had, I think it was this 36 one. Okay, because the most efficient is the first sodium peaks. It's the lowest energy. So, let's see. So there's that. So now I need to do that again right here. And so this is the lower energy sodium. And so the lower energy sodium is, yeah, 1.79. So that seems weird, obviously. But if you took 180, I mentioned this earlier. So if you take 180 and you divide it by 2, it's 90. And so 90% of the time it decays this way, but this is an annihilation decay. It's positron decay that annihilates and emits two gammas. And so you have to account for the fact that there's two gammas. So it's 90% times 2, so 180. So I need to do 1.799 times that. Pretty straightforward. Okay, go ahead and run that. So that puts my uncertainty up to 5.7. 5.7, 5.7. This was at, what's this one? This one is 4.2 and then 5.7. And then now here, this one gets multiplied by, let's see. I'm gonna make this easier on myself here in a second too. So this one needs to be multiplied by 0.99. So it's effectively, I can keep the second one. It's 0.999. I mean, I'm going to multiply it, but it's the same thing. Make sure I do a 0.999. Won't be the same if I did 1,000 times. That run, I don't know if it ran. Let me see. It shouldn't change much. Yeah, that one's still 2.4, so that's fine. So what I'm going to do now to make things easier on myself, which I alluded to just a second ago, is I'm actually going to name these EFCS. So then I just need to change this to CS. CS. Right, it shouldn't mess anything up. It does not. Because what I'm going to do now is I'm going to call them when I get to my fit functions. And so now I'm going to do EFNA1. And then recall this EFNA1 and EFNA1. Go ahead and run that. So the reason I'm doing this is so when I get down to my array that I'm going to build, because I got to refit everything now because they've all been scaled. So Who knows? Maybe it'll fit a little bit better. I don't think that it'll be that much better, but what are you going to do? So this will be Na2. So then subsequently Na2 and Na2. Go ahead and run that. And so now what I can do, when I get down here, the efficiency array is going to be, oh, I can't do that, can I? Because they're printing as U floats. Boo. Well, I guess I could do it as the nom value, but I don't really feel like doing all that. So whatever. I tried. So it's gonna be, I need the highest efficiency. Well, I need the lowest energy. So the lowest energy is this 511 keV. So that goes with Na1. So whatever Na1's efficiency is, which I believe is 5.7. Find it. So that's cesium. Guess I should probably name these so I know which one's which. That would probably make my life a lot easier. Let me do that. Cesium. Name C. What do you? Oh, I have to put it in quotes. The formatting kills me sometimes. There we go. Now this is gonna be 511 A. That okay, good. And then the other one is 1175 NA. Let's see. Good. What time we got? Got about a minute left. I'll go ahead and cut it here. And while I'm waiting for the video to download, and then start a new meeting and re-record, I'll go ahead and fit the array for you guys. I won't fit it, but I'll re-input the array, so you guys don't have to deal with me just going back and forth with that. Alrighty, so I will see you guys in a minute.